Hello everyone, welcome to session 2, unit 4 theory of simple bending. Hope you all enjoyed first session. So we'll start with second session, remaining topics. In first session, I covered the concept of theory of bending, then bending formula, a few assumptions of theory of simple bending, and this session we'll start with what is section modulus or modular section or modulus of section. Section modulus is defined as the ratio of moment of inertia of the section to the distance of the remote layer of the neutral axis. So the section modulus we are represented by letter Z. It is nothing but as formula as explained before. It is a ratio of the moment of inertia I to the distance of remote layer from the neutral axis Y. It is also defined as it is the ratio of bending moment M and the maximum bending stress Fb, and the unit of section modulus is meter cube or mm cube. So you can see the formula, the bending moment M by the bending stress is also section modulus, and the moment of inertia I by the distance of the remote layer from the neutral axis Y is also section modulus. Finally, mathematically, the M by Fb is equal to I by Y is equal to Z, that is section modulus. So we'll see the section modulus for rectangular section and circular section. From the formula you can see I already explained the moment of inertia by I by Y is equal to section modulus. The Y is nothing but that is depth by 2 in rectangular section, d by 2, and the moment of inertia of rectangular section, this I have already explained in unit 2. So that is BD cube by 12. So the section modulus Z is equal to I by Y. Substitute I and Y value to the Z. I is nothing but BD cube by 12 and Y is nothing but D by 2, that is equal to BD square by 6. D cube 1D out hoಗುತ್ತೆ, then 2 6 are 12, then finally BD square by 6. And the second one is circular section. As like rectangular section, the moment of inertia of circular section is equal to pi d to the power of 4 divided by 64, and Y is equal to d by 2, diameter by 2. In rectangular case it is depth by 2. In circular section, that is diameter by 2. Now substitute I and values to the Z formula. Z is equal to pi d to the power of 4 divided by 64 and the Y is d by 2. Finally the answer is pi d cube by 32. Sorry, that is like typing mistake. Pi d cube by 32. The Z for circular section is pi d cube by 32. Now flexural rigidity. What is flexural rigidity? The product of EI is called the flexural rigidity of the beam. The moment sustained by the element of a beam is proportional to EI. The larger the value of EI, the larger will be the moment sustained by the beam. It is an index of flexural strength of the beam. The flexural rigidity is equal to E into I, and the unit is Newton per mm square. The product of EI is called flexural rigidity. From the formula M by I is equal to, we know the bending equation, M by I is equal to F by Y is equal to E by R. The flexural rigidity is nothing but it's a product of E into I. To get the product of EI, we have to take M by I is equal to E by R. Now the moment M is equal to EI divided by R. Now the product of EI is called flexural rigidity. Now the strength of section. What is the strength of section? It is also termed as a flexural strength of the section, which means the moment of resistance offered by it, which means the moment of resistance offered by it. You take m by I is equal to fp by y from the bending equation. Now the m is equal to fb into I by y. We already know I by y is nothing but z. The moment m is equal to, now it becomes fb into z. It is very important formula. ಅದು ತುಂಬಾ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬೇಕಾದ್ರೆ ತುಂಬಾ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಇದು. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. Now the modulus of rupture or maximum bending stress. It may also defined as the maximum bending stress required to cause the bending failure of a beam. It is used as a yardstick to compare ultimate bending strength of beam of various size and materials. M by I is equal to fp by y. The fp maximum, that is equal to m max y divided by I. So the fb, it came again, it won't be there. So fp maximum is equal to m max y divided by I. The bending moment for different conditions, these you might have already aware from the third unit, shear force and bending moment. This is just direct formula to remember. Direct ಏನಾದರೂ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟರೆ ಈ ಕಂಡೀಷನ್ಸ್ you can apply directly. So different cases ಯಾವ್ಯಾವ್ದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಸ್ಟ್ one cantilever beam with a point load. For that you already know what is cantilever beam. M is equal to W into L. W is nothing but load, L is the span of the beam or length of the beam. So ಅದೇ ರೀತಿ second one is the cantilever beam with UDL. So the load is in kilonewton per meter. So moment M is equal to W L square by 2. Simply supported beam with point load at center, point load at center. The moment M will become W L by 4. See, the fourth case, simply supported beam with UDL. So that is equal to M is moment is equal to W L square by 8. ಈ ಒಂದು ಫಾರ್ಮುಲಾಸ್ ನಿಮಗೆ ಡೈರೆಕ್ಟಾಗಿ ಈ ಥರ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಾಗ ಥಿಯರಿ ಆಫ್ ಸಿಂಪಲ್ ಬೆಂಡಿಂಗಲ್ಲಿ ಸೊ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು ಡೈರೆಕ್ಟಾಗಿ. ಸೊ ಇನ್ ಕೇಸ್ ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಬೀಮ್ ವಿತ್ ಪಾಯಿಂಟ್ ಲೋಡ್ ಅಟ್ ಸೆಂಟರ್, ಅದರ ಸೆಂಟರಲ್ಲಿ ಇಲ್ಲ, ಸಮ್ವೇರ್ ಈಸ್ ಗಿವನ್ ದ ಪಾಯಿಂಟ್ ಲೋಡ್ಸ್, ಯು ಡಿ ಎಲ್ ಈಸ್ ಗಿವನ್ ಇನ್ ಸಮ್ ಅದರ್ ವೇ ಅಂತ ಹೇಳಿದರೆ ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮೂಮೆಂಟ್ ಯುವರ್ ಸೆಲ್ಫ್. ಲೈಕ್ ಥರ್ಡ್ ಯೂನಿಟಲ್ಲಿ ಯಾವ ಥರ ಮಾಡಿದರೆ ಮೂಮೆಂಟ್ನ ಆ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ಬಟ್ ಈ ಕೇಸ್, ಈ 4 ಕೇಸಲ್ಲಿ ಯಾವುದೇ ರೀತಿಯಾದ ಪ್ರಾಬ್ಲಮ್ ಡೈರೆಕ್ಟಾಗಿ ಕೊಟ್ಟರೆ ಇದೇ ಥರ ಯು ಕ್ಯಾನ್ ಪುಟ್ ಡೈರೆಕ್ಟ್ಲಿ ದ ಮೂಮೆಂಟ್, ಇದೇನು ಫಾರ್ಮುಲಾ ಇದಿದೆ ಹಾಕಿದರೆ ಆಗುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ರೆಫರೆನ್ಸ್ ಬುಕ್ಸ್ ಯು ಕ್ಯಾನ್ ರೆಫರ್ ಅಂಡ್ ದಿಸ್ ಆರ್ ದಿ ಲರ್ನಿಂಗ್ ವೆಬ್ಸೈಟ್. ಥ್ಯಾಂಕ್ ಯು ಆಲ್. ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ದಿ ಸೆಷನ್ 2. ವಿಲ್ ಕಂಟಿನ್ಯೂ ವಿತ್ ಥರ್ಡ್ ಸೆಷನ್. ಐ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಫ್ರಮ್ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್. ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಬರುವಾಗ ಕೇಳೋದಕ್ಕಿಂತ ಮುಂಚೆ ಗೆಟ್ ರೆಡಿ ವಿತ್ ದ ಪ್ರೀವಿಯಸ್ ಸೆಷನ್ ಫಾರ್ಮುಲಾಸ್. ಸೊ ದಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಟು ಸಾಲ್ವ್ ದಿ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಫಾರ್ಮುಲಾಸ್ ಎಲ್ಲ ಸ್ವಲ್ಪ ನೋಡಿ ಬನ್ನಿ. ಸೊ ಅದು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಸೆಷನಿಂದ ಇದು ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಸಿ ಯು ನೆಕ್ಸ್ಟ್ ಸೆಷನ್. ಥ್ಯಾಂಕ್ ಯು ಆಲ್.